Community-based recycling programs are more popular than ever. Reducing the waste stream to already jammed landfills by recycling plastic, glass, metal, and paper just makes sense. It also makes environmental awareness part of our daily routine. Most people don't realize, though, that the 200 gallons of wastewater a typical family of 4 generates every day can also be recycled. Once wastewater leaves a home, it's processed at treatment facilities where liquids are separated from solids, purified, and then safely returned to waterways. The solids are also processed to eliminate any disease-causing bacteria, viruses, and parasites. What remains is a nutrient-rich natural fertilizer known as biosolids. For years, these biosolids were inefficiently landfilled, ocean dumped, or incinerated. But today, with restrictions tightening and costs for landfilling and ocean dumping rising, communities are realizing the benefits of biosolids recycling. Currently, agriculture is the #1 outlet for biosolids. Through biosolids application, rich organic nutrients can be restored to overworked soils, thereby increasing crop yields. Restoring nutrients to agricultural lands seems the most logical use for biosolids, but alternative applications have been around for years. In the bituminous coal fields of north-central Pennsylvania, biosolids are used as a soil amendment to reclaim surface mines. After spent mines are backfilled and recontoured, biosolids are incorporated into the soil. The soil is then reseeded as the final step of the reclamation process.
The field behind me is part of a mine site known as the Mountaintop Mine, and the biosolids application started almost 5 years ago. This spring will be 5 years. Biosolids compared to commercial fertilizer application have very similar germination times and initial establishment. The biosolids become much more impressive after the first year, when everything seems to come together and you get a bloom of growth. Biosolids, by their organic nature, are slow release, so it's sustained for significant periods of time.
The biosolids are trucked to the mines from Philadelphia. The city's 72-acre biosolid recycling center is one of the largest centralized biosolids processing facilities in the country and has been recycling the solids from wastewater generated by 2.3 million people into biosolids for over 20 years.
The Philadelphia Water Department made a commitment back in the mid-70s to the EPA and to the state agency that would end the practice of ocean disposal and embrace land application of biosolids. One of our longest standing programs has been the program to reclaim strip mining lands. And over the last nearly 20 years now, we have reclaimed about 4,000 acres of land using 700,000 tons of biosolids products.
For surface mining reclamation, biosolid application is actually the preferred fertilizing program. But even with programs like this, 1/3 of all biosolids being processed nationwide still remain unused.
The facilities are continuing to produce this product. Most of them have established programs to either land apply or use or dispose of this, but only 50% of the usable biosolids is actually land applied for beneficial purpose.
Developing and implementing better ways to use this excess is crucial. For the last 30 years, scientists at the USDA Agricultural Research Service in Beltsville, Maryland, have been experimenting with alternative uses for biosolids. With an eye towards hazardous waste sites, and in particular contaminated smelter and mining operations, these researchers believe that biosolids have real remediation potential.
So it works good on coal mines. What does it do about zinc mine waste? I see it as a straightforward extrapolation of available knowledge applied to one of the toughest problems the environmental agencies have of barren, contaminated mine waste and smelter polluted mountains that had been barren since 1950 or longer in some cases.
Through a collaboration with U.S. EPA's Environmental Response Team, the USDA has found a partner that, if the technology proves itself, could make a sizable dent in the surplus of municipal biosolids.
Biosolids or composted biosolids technology seem to be most appropriate for metals contaminated sites, and specifically we're encouraging their use at large area metal sites where they're looking at literally hundreds of acres or even square miles of contaminated mine land from base metals mining or smelting.
Soil samples from these EPA sites are shipped to the USDA's Environmental Chemistry Lab, where they're blended with composted biosolids and other amendments like limestone. These tailor-made biosolids not only jumpstart plant growth by increasing fertility, but they also have the ability to fix or bind heavy metals, thereby reducing their phyto and bioavailability. Simply put, the contaminants are still present in the soil, but can't be absorbed by plants or animals. Even if they're ingested, they remain bound as part of a compound and are safely passed through the digestive system.
The USDA folks basically give me a recipe of biosolids addition and lime addition and other to give me the optimum conservative treatment for the kind of application we would perform.
With the USDA's recommendations in hand, EPA recently teamed with the city of Denver to conduct field-scale testing along the floodplain of the Arkansas River. Mining in that region of Colorado, particularly around the town of Leadville, had been a boom to the region for over a century, but not without a cost to the region's pristine alpine environment. During seasonal flooding over the last 100 years, mine tailings were deposited along the river's bank. The silt contained elevated levels of heavy metals, which killed vegetation, escalated erosion, and stripped what little topsoil remained.
This material from the mills entered the Arkansas River, and from there they entered the irrigation ditches. So a lot of waste material, high in metal content, came down all the streams.
To try to get these soils healthy enough to support plant life again, 15 to 20 truckloads of biosolids are being hauled every day from Denver Metro's wastewater treatment facility, which has the resources to process, custom blend, transport, and land apply biosolids.
Metro Wastewater Reclamation District's biosolids are an excellent quality biosolids. We have an outstanding pre-treatment program which prevents unwanted materials from getting here in the first place. We have an outstanding laboratory program for analyzing the biosolids, and we produce a material that far exceeds the EPA's requirements for what's called an EQ biosolids with respect to metals.
Collaborating with biosolid specialists on site as well as in the lab has allowed researchers to experiment with different mixture ratios and application techniques on a larger scale.
When you're going to a certain site, you have to look at the site, discuss, try and figure out what the problems are at a site that are limiting plant growth, and based on that come up with a specific amendment for each site that'll try and address each of those problems. What you can do with the biosolids is mix lime directly in. It's a very straightforward procedure. Just by turning it around a little bit with a loader, you can get a decent mix. And what you have when you add the biosolids and the lime together is the potential for the alkalinity that you're adding with the lime to move through the profile with the biosolids, so that you can not only fix the acidity at the surface 6 or 10 inches, but hopefully you'll get down to 24 and even further.
Analytical results of pilot tests at Leadville indicate that the biosolids treated soils reduce the available metals, thereby reducing lethal toxicity to living organisms. What this means to the locals is that after almost 100 years, the land can finally be put back to productive use.
As these historic mine wastes are revegetated, the landowners hope to have some forage suitable for raising various types of livestock, and we will have an area along the upper Arkansas River that will support fish life, be a wonderful wildlife habitat, and be an enjoyable place for people to come and play.
USDA and EPA are also collaborating at another metals site near Kellogg, Idaho. At the abandoned Bunker Hill smelter facility, airborne contaminants killed plants along the hillsides, leaving the soil susceptible to the forces of wind and rain. The erosion then stripped the steep slopes of nutrient-laden topsoil and any hope of natural revegetation.
When you have a site like this, you have problems associated with poor physical properties of a soil. That's basically a result of there being no more organic matter left in the soil. Biosolids are about 50% organic matter. So when you do a heavy biosolids application, you're rebuilding a lot of the organic matter in the A horizon of the soil. Biosolids are basically your whole recommended nutrient table for plants. Nitrogen, phosphorus, some potassium, calcium, magnesium. There's a whole long list of elements that are essential for plant growth, and biosolids have basically all of those elements. There are two aspects of the biosolids project at Bunker Hill. We've treated uplands with biosolids. That's been in place for about 3 years, and we treated a wetland with a biosolids compost, and that's been in place for about 1 year. We've been real happy with the results we've seen so far. The biosolids on the uplands portion have maintained a really vigorous vegetative cover for the 3 years that they've been in place. Here, you see this opening here. What we used was biosolids in combination with wood ash on the hillsides. The wood ash is a locally available residual. It's very high in phosphorus and potassium, and it's a very high calcium carbonate equivalent material, so you're getting a lot of limestone when you're putting down wood ash. In addition, they get to be a very highly adhesive material, so they'll stick to the hillsides. In the wetland, what's really nice is that now when you drive past the wetland, you hardly blink because it looks like a wetland, like any of the wetlands in the area, whereas before it looked like it was filled with quicksand.
Initially, communities were somewhat skeptical of biosolid recycling, but fears of pathogens and naturally occurring heavy metals in biosolids are being replaced by enthusiasm. Inviting local representatives to visit application sites and biosolid processing plants is also beneficial. Usually, once a community realizes the cost benefits as well as the advantages over traditional treatments, they're more willing to accept biosolids recycling as another green solution.
Politically, it's very cost-effective as well because most folks out there appreciate seeing a landscape of lush green and or trees rather than cement or denuded landscape.
It's a very promising technology. It's inexpensive compared to other technologies, and it takes two wastes, sludge and waste land, mining wastes, mixes them together and gets a positive result. And it'll be a very, very useful technology in the future.
This isn't a 1 year or a 1 season fix because we correct all the problems the soil had from the pollution. All the science says it's fixed persistently. The design makes it fixed persistently. And I'm confident from, again, the basic research side and the experience side that it's the persistent remediation that we've been seeking for these many years.